Lecture 9, Heat Transfer. Heat transfer is a transfer of heat from region of high temperature to a region of low temperature. Driving force is a temperature difference. Mechanisms of heat transfer. One, conduction or first conduction is a transfer of energy from one molecule to the other adjacent to it without displacement of particles. It is the main mechanism in case of solids like metal rod. Number two, convection. It's a transfer of energy from region to another by motion of fluid, water. Heat is transferred from lower layer to middle to upper. It's confined to fluids, liquids, and gases, not solids. It may be natural or forced by mixing. Number three, radiation. All bodies with temperature above absolute zero radiate heat in the form of electromagnetic waves, which travel in a straight line at a speed of light. Radiation may be transmitted, reflected, or absorbed. The absorbed fraction of is transformed into heat, like sun or IR lamps. Source of heat energy. Direct, like flame or electrical heater. Indirect, it involves two steps: transfer of heat from one system to heat transfer agent HTA, then transfer of heat from HTA to second system. Steam, it is very high heat content. Steam has very high heat content. It's used to give both sensible heat and latent heat. The raw material water is cheap, clean, odorless, and tasteless, so its accidental contamination is not serious. Steam is generated in a boiler by fitting a valve that will not open to allow the escape of steam until certain pressure is reached. As pressure increases, boiling point of water increases, steam temperature increased. Types of steam. Number one, saturated steam or wet steam arise directly from boiling water, easily condensed on any cooler surface due to presence of suspended water droplets, which may be heavy on steam, so it will be condensed easily. Unsaturated steam or dry or live steam, its pressure less than that of wet steam at the same temperature, not condensed on a slightly cooler surface. And superheated steam is number three, obtained by heating a saturated solution away of contact with its liquid state, not used as HTA because it behaves like a gas. One, steam dryer or steam separator. They are used to separate water from steam. Steam rapidly change its direction so that the water is left behind and then the dry steam go forward. Like simple type like this, steam go like this and water will condense here, leaving dry steam to go out. Or by the screw type, which makes steam go like this, having water to be condensed and left behind. Steam traps, it's used to prevent outlet of live steam or removal of water collected in steam dryer. Mechanical, number one of it, mechanical float type steam trap, depend on physical difference like this. Then there is a thermostatic steam trap, balanced pressure expansion steam trap like this. It depends on expansion of different liquid or different metal. It consists of a closed capsule made of copper alloy and fixed at the top. It is corrugated surface. It contains liquid with a boiling point lower than that of water. Then the capsule is surrounded by steam. The liquid inside it will boil and capsule expand and the outlet is closed, and vice versa when there is no steam or no heated steam. Thermal insulation, it's used to prevent heat loss. A good lagging material should have low thermal conductivity and suppress convection currents. Example of lagging material like cork, asbestos, 85% magnesia with asbestos. Economic thickness of lagging: as thickness increase, heat loss decrease, but cost is increased also. So there is an optimum thickness. Small pipes need a small thickness and vice versa. Fourier's law of heat transfer, Q equals Q over T equals QA T1 minus T2 over L. Q is the rate of heat transfer, K thermal conductivity coefficient, A area, T temperature, L thickness. The proportionality constant is termed thermal conductivity of the material is denoted by the symbol K. It gives an indication of the ability of material to conduct heat. The higher the value, the more easily heat is conducted by this material. Heat transfer may be a heat exchanger, may be tubular or special type. Tubular heat exchanger number one, single pass tubular heater. It consists of a bundle of parallel tubes surrounded by a cylinder shell and provided with two distribution chambers. Steam is introduced from opening F into the space surrounding the tubes. The condensed steam is drained from the drips like this. Feed is introduced from here to go out from here. Steam is surrounds the pipes or the tubes, which is very thin to pass the liquid, making heat transfer from steam to the liquid. It's called one heat exchanger. There is a vent in it for used steam and drip for condensed liquid from steam. Number two, fixed heat exchanger 1-4. There is a baffles to increase the velocity of flow outside the tube, giving better heat transfer. Disadvantage: tubes can't be expanded freely. Tubes can't be removed for cleaning like this. We elong the path of liquid to be more heated or to be more efficiently heated. Floating head heat exchanger. There is a floating head here. There is floating head here, permitting expansion. Advantage: tubes can be expanded freely, can be removed for cleaning. What are the factors affecting the efficiency of tubular heat exchanger? According to Fourier's law, tubes must be of increased thermal conductivity, tubes must be long, tubes must be thin, tubes must be of in high number. Special forms of heat exchanger like plate heat exchanger. It consists of a series of parallel plates supported on a frame. The hot fluid pass between alternating pairs of plates, exchanging heat with cold fluid in the adjacent spaces. Advantage: produce large surface area for viscous liquid, easy to clean, can heat more than one liquid at the same time without mixing them, like this. Number two, in the special types, spiral heat exchanger or FRISER. Two liquids flow counter-currently through the channel formed between the spiral plates, suitable for heating and cooling products which are highly viscous, can be used for highly viscous like cream, ointment, lotion, or containing solid matter, whose viscosity change during heat exchange products which have tendency to crystallize, like calcium carbonate or calcium sulfate or magnesium sulfate. Advantage: a large surface area in a small place, low cost, reduction in energy consumption, velocity very high, or heat transfer coefficient is very high. Scrubbers cause the product to be conveyed from the inner surface of each chamber to the outer surface. This results in rapid exchange process without any significant amount of heat loss. Find tube heat exchanger. It is used for heat transfer between air, gas, liquids, and steam.